First up, the woman who came to be called the mother of the Hubble Space Telescope.
When Nancy Grace Roman was a girl in Nevada, the night skies were dark and clear, perfect for stargazing.
Probably between 5th and 6th grade, I organized my friends into a club that met once a week to study the constellations.
Fascinated with the stars, Nancy Grace always wanted to be an astronomer. That may seem reasonable to you, but back then, it was very unusual for a girl to want to be a scientist.
Well, I've had my year of general science, and I see no reason why I should take another course next year when I'm a senior. I don't want to be a scientist.
She just wants to hook some guy.
All right, so I want to get married and have a family. Is there anything wrong with that?
Nothing, except your idea that you'll never need science to keep house.
My high school guidance teacher, when I went to her and said I'd like to take a 2nd year of algebra instead of a 5th year of Latin, looked down her nose at me and asked, what lady would take mathematics instead of Latin?
Nancy Grace became an astronomer, but in those days, women scientists did not have the same opportunities or job security as men.
I was actually an instructor and an assistant professor at the University of Chicago. But I realized I had no chance of tenure. I didn't know of any woman who had tenure in a research observatory.
About the time the space program got underway, Nancy Grace went to work for NASA, where she helped launch satellites called observatories to study the stars and the sun.
The Orbiting Astronomical Observatory's primary mission was to get ultraviolet observations of the stars.
Ultraviolet pictures taken by these observatories showed scientists energy we can't see with our eyes.
Looking through the atmosphere is pretty much like looking at a street light through a piece of old stained glass window. Because the stained glass is colored, you only see certain colors. Our eyes are sensitive to colors that come through the atmosphere, but there are a lot of colors that don't come through the atmosphere. Secondly, the old glass, has defects in it, and that blurs the image.
The ripples in the glass.
Right.
They act like
or
lenses.
Little bubbles.
Yeah, or bubbles, yeah, okay.
And the atmosphere has the same kind of ripples and bubbles.
Yeah.
Next, the dust on the glass scatters the light, so we have a background. Well, in the same way, the molecules in the Earth's atmosphere scatters the light. That's why we don't see stars in the daytime, because it's all scattered sunlight. So for those reasons, we wanted to get above it.
These images help them to figure out the chemical makeup of the sun and the stars. Not only that, Nancy Grace helped to get the most famous observatory of them all into space, the Hubble Space Telescope, an ambitious project.
Astronomical objects, except for the sun, are faint.
Yeah.
And in order to observe anything that's faint, you need to have a lot of area to collect the radiation, to collect the light.
Yep.
So you need a big telescope in order to see faint things.
What I'm hoping is that you will tell us at least where the mirror is in this telescope and what the mirror does. Can you point those things out to us?
I think the mirror is below the lower yellow.
Okay, and where does the light come in? That's what people always want to know is where does the light come in?
Well, the light comes in way up at the top.
Yeah.
And it comes down here almost to the smooth part of the telescope. And that's where the mirror is. And it comes all the way down to a mirror that's in this sort of the widest section there with the doors and the grating.
Above that white patch.
Above the white patch.
And with those two sort of vents in there.
Right.
Yeah, okay.
And then it goes from the mirror, which is there, up to a second mirror, which is almost up to the top of the telescope. And then it comes back down and goes through a hole in the middle of the first mirror to the instruments which are below the mirror.
Yeah.
She worked to get the funding from Congress and gathered scientists and engineers together to design and build the Hubble. The Hubble was finally launched in 1990. The Hubble has captured some of the most extraordinary images of our universe ever seen. We can see nebula where stars are born or die, the remnants of a violent supernova, energy from a mysterious star, galaxies that are barely visible from Earth, and galaxies so far away we never even knew they existed until a time-lapse shot from the Hubble Space Telescope revealed them. When Nancy Grace looks back on her decision to take her first job at NASA, she realizes she was a bit nervous.
But I thought the challenge of starting with a clean slate and mapping out a program that I believed would influence astronomy for 50 years was just more than I could resist.
From a little girl who loved to look at stars to a woman who helped launch the Hubble Space Telescope, Nancy Grace Roman is a true pioneer.
To me, the thing that I'm most proud of is the discovery of dark energy.
By calling it dark, what do astronomers mean by calling it dark energy?
Well, I think primarily at this point when we're talking about dark matter, we simply mean it doesn't interact with light in any way.
Right.
Dark energy doesn't react with light in any way either, as far as we know.
Yeah.
But secondly, it's very mysterious.
Very mysterious, yeah, but very exciting.
Yes.
Well, Nancy, thank you very much for coming by today and
You're welcome.
helping us appreciate the Hubble Space Telescope a little better.
Well, good. glad you asked me to come.
Great.
Up next, a first for space science and a first for women in space science.
Anne Merworth was a determined girl. She didn't let anything get in her way.
I had been raised in a family that taught me that whatever you wanted to do, you could do.
But when she was growing up, boys got to do science.
Right here. See, what's inside this little man? What's inside this little man? And what's inside that little man? Well, I'll give you a clue.
And girls worried about getting married.
Father and I are practically engaged. Mama says I can't wear lipstick until I'm 16, and I wouldn't want to get married without lipstick.
When she got to high school, Anne decided she wanted to be an engineer.
I wanted to go to Georgia Tech, and I applied, but it was an all-male school. I found shortly thereafter that most of the engineering schools were male schools in the 1950s.
Anne went to Emory University, where she studied math, physics, and chemistry.
When I graduated from college, one of the first places that I interviewed for a job was IBM in Atlanta, and they showed me two pay scales. Here's the pay scale for women, right next to it the pay scale for men, at about 35% higher for the men.
That was completely unacceptable, so she kept looking.
If it's something that is attempting to keep me from going the direction I want to go, I usually just get stubborn and keep on pushing on through, thinking somehow it'll be all right.
Anne got a job at NASA working in computer programming. Computer programming was considered really boring, and because of that, it was considered women's work.
So I went out and looked around for what else was going on at the center, and I found a place where there was research going on putting a computer on board a satellite.
Back then, satellites worked like remote control cars. We could only send or receive information when the satellite was in range of a radio transmitter. We couldn't control it from the ground. If it stopped transmitting, there was not much that could be done.
They needed a software person that could write the operating system.
Anne wrote the operating system for the first NASA computer to go into space. For the first time, crew on the ground could upload new commands to change the satellite's mission, or troubleshoot, or make repairs. Anne became a leader running major projects like the operations upgrade of the Hubble Space Telescope. Still, there was a problem. Anne loved her work at the Goddard Space Flight Center in Maryland, but she needed childcare for her son. There were no good daycare centers nearby.
So I decided that Goddard should get into the child care business.
Anne found a building, hired teachers, and set up a child development center, the first daycare center at NASA or at any federal agency. Now women wouldn't have to choose between working and caring for their children.
That was something that I really needed and other women needed in order to be comfortable in the workforce.
Of all of her accomplishments at NASA, Anne is most proud of starting the school.
As I look back, that was probably my most significant accomplishment. And I ran into a woman whose child was in the Child Development Center, and she was so pleased to meet me because the school had been such a godsend for her. And clearly, I think the school and the women's program work that I did stand out.
Anne Murworth's work made a lasting difference. She helped expand our knowledge of the universe, and she expanded opportunities for mothers in the workforce.
Last up, a truly hidden figure. In this video, I'm going to talk about someone who I think I can guarantee you have never heard of, but whose work sits in your pocket every single day. She's also the first Black woman to have ever run a project that launched a satellite. Her name is Dr. Gladys West, and the last time I talked to her, she was 100 years old, and she is still around, and that was 2.5 years ago.
Most of the time, my brother was ready to go out the door to play. But I sort of thought like grown-ups did. I feel like, well, you're wasting your time now. You need to be getting so-and-so done.
This was in rural Virginia in the 1920s, so deep in the segregated South.
We couldn't go into any stores and go in the front door. And you go downtown and you see buildings with the black only, white only or something. So you obeyed that rule. And the rules were you have to call them Miss and Madam. You can't call them by their first name.
There were not a lot of careers that Black women could hold back then, so Gladys was lucky. In high school, she first started to realize that she was really good at math. Math was her ticket out. It got her off the farm, and it brought her to the campus of the all-Black college near her, Virginia State University. At VSU, she learned another important lesson, and that was what it meant to have a female role model. In her case, Dr. E. Louise Stokes Hunter, who was the first Black woman ever to earn a degree from the all-white University of Virginia. Just to give you an idea of what a big deal Dr. Stokes Hunter was, in the 100 years between 1869 and 1969, in those 100 years, only 58 Black women ever got a PhD in a STEM field, and Dr. Stokes Hunter was one of them. She's also the first Black woman to get a degree from Harvard. She got a master's degree from Harvard, and then she got her PhD from UVA. Gladys lived in the home of Dr. Stokes Hunter and her husband, Dr. John McNeil Hunter, who was the third African-American man ever to get a PhD in physics.
I mean, they were examples, living examples of what I could do. I could have the kind of house they had. I could eat the type of food. She's a mathematician, and I learned that there was a possibility that I could be like they are.
Gladys got a math degree, and then in a little while after that, she got a letter from the U.S. Navy Surface Weapons Center in Dahlgren, Virginia. America had just won World War II, and during the war, all of the nation's technological resources went to the war effort. So everything from corporations, everything from universities, anything in electronics, anything in communication, anything in computers. So at this point after the war, the Navy was one of the principal places for technological excellence in the United States. And what they needed more than anything else was people who were good at math.
We had all these big computer models coming in, and we were going to be able to process a lot of data and learn a lot about our environment. And so they chose the mathematicians instead of maybe an engineer or something other field. So we were at ground zero starting.
The first place that Gladys worked was with an IBM computer called the Naval Ordnance Research Calculator. Everyone just called it the NORC.
The NORC calculator was a humongous machine. It filled up a big room.
As I mentioned, she helped lead a team. They launched CSAT, the first satellite to gather information about the oceans.
We have checkpoints and keep checking, see how far we got. And then finally, when we think we've got it all done and we need to we give that program over to another person with the results that we found.
The lines of authority were really squishy at Dahlgren at that time. And Dr. West says that in the government, you never really knew who the ultimate boss was. But she says that one thing that was clear was the racial nature of the command structure.
You know, if you had a black boss, you always had a white boss over the black boss. So I guess it was never, I didn't end up being a real long-term team lead, but I was always in charge of some little group of people.
Regardless of that, and maybe most important, Gladys made some of the calculations that taught humankind the true shape of the planet that we live on. It turns out it's not a globe. When they measured the Earth and figured out how deep the oceans were, they learned it's actually shaped like this. It's a geoid. Because of those calculations, all of our GPS satellites sit in just the right place in outer space today. It's a long way from the tobacco fields to outer space, but through it all, Gladys West had an inner spark that kept her going, a drive to never sit still.
I've never felt restful. I felt like there was something always after me, and I had to get something done. I had to keep moving, getting something accomplished, learning something. I have a little bit of that now too, but at 100 years old, you can't expect too much.
If any or all of this is news to you, I have a book I want to suggest. It's the one behind me, We Could Not Fail, which I wrote along with Stephen Moss. There's a paperback version, and you can also get it in an audiobook form from Audible.